complete functions. What is the meaning of complete function? If I am going to give certain inputs as A and B, it is going to produce the exact function value of its output, right? If I am going to say that 0 and 0, its output is 0. If I am going to produce like 0 and 1, its output is 1. If I am going to produce like 1 0, input is 1 0, its output is 1. If I am going to say that its inputs are 1, its output is 1. Meaning that for each and every input, I am going to have certainly one output. That kind of function I am going to call it as complete functions, right? Certain times there are certain kind of functions are there, those are incomplete functions. Those are incomplete functions, right? For complete functions, what are the terms are available here? What are the terms are available? All ones can be included as a complete function, right? One is a bar b, another one is ab bar, another one is ab. This is a kind of a complete function. If I am saying that it's an incomplete function, there should be certain output which you cannot able to define. For example, I am trying to function called fk function 0, 1, pi, and I am saying that this is 1. What is the meaning of this one? In this function, there are certain terms which I didn't define. Which I didn't define. Those terms I can call it as don't care terms. Don't care terms. You should not care about all those things, right? Meaning that this may vary from two values. What are those values? At certain times it may act as 0, at certain times it may act as 1. This is what don't care terminology. Don't care means they may act as 0 or they may act as 1. Okay, fine. For example, if I am going to have this meaning, how many functions are possible? One is 0, 1. 0, 1 is one function possible. What is another function? So fk1 is one function. fk2, what is another function is possible? 0, 1, 1, 1. This is the functionality possible. That is the meaning of don't care. For example, I am trying to define some of the terms of 0, 1, 2, 3, 9 plus you have to consider don't cares 8, 10, 11, 13. Can you able to simplify the expression? Right, try to observe. Right, if you take any k map, how we are going to represent, you know, right? So I think I can take some terminology like ABCD. This is 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. What are the values of this 0, 1, 2, 3, 9? I think 0, 1, 2, I think 3. What is 9? 1001 is 9. Am I right? 1001 is 9. What about don't cares? You should not care about them, right? So wherever they are saying that don't cares, you have to mark them, right? What is 8? I am going to mark them as don't care, X, cross mark. 10, I think 8, 9, 10, 11, and 12, 13. 12, 13. Now what is the resultant expression you are going to get? You have to consider what are the possible functionalities. In place of this don't care, you may get zeros or you may get 1, right? So now in order to get your expression is very minute simplified expression, these don't cares can you consider or you may not consider. If you consider, what will happen? If you are going to consider, in place of this cross mark, I am going to consider it as 1, meaning that don't cares I may consider as 0 or 1. If I consider 0 or 1, what I can do? I can combine this as 1 or not. Yes. So I got a maximum of 8 terms. If I am going to combine maximum of 8 terms, what is the output you are going to get? B bar. That is the advantage. Guys, can we combine these two now? Can we combine these two? If I combine these two, you are going to get extra term. Why you need to consider? Because it is all, this one is already covered, so you should not consider, right? So that is why you are going to work.